Hello and welcome to another tutorial video for Thinking Particles. In this video we will talk about our new MEL programming language we have added to Thinking Particles version 7.3. This is a very powerful scripting language that allows you to create your own Thinking Particle nodes, and those nodes will perform faster or as fast as native nodes of Thinking Particles. Before we start, let's have a look at the scene. We have a very simple, straightforward scene. We have this spotlight. It's animated and it's moving around, illuminating our plane, the torus, and our sphere. So very simple, straightforward setup. And to start this tutorial video, we are going to just create our Thinking Particles helper. I'll click it in here. And now we have the Thinking Particles helper activated. We go to our Modify panel and start up our setup. So the first thing we want to do is create a particle group. And I'll name this particle group Spray, and also what we want to do is create our dynamic set where we do the setup. So I'll name that Create. The next thing we are going to do is add our MEL operator node. We can do this in many ways. There's different ways to do that, but I like right now to use the right-click menu. So we do a right-click into the dynamic set view, and then you will see that there is a new MEL entry in the menu. And this new MEL entry shows you all the Thinking Particles nodes that have special connections or special features that support MEL programming. Mainly those nodes have extra support for multi-threaded execution, so they will run much faster and highly optimized when accessing particle data, for example. Let me now choose my MEL expression operator node, and I'll just click it in here, and we can see right away there is nothing I can connect and do with it except clicking on the editor button. And let's do that now. So this will bring up our scripting editor or programming editor, and in there, when you bring it up the first time, we add some basic information, some comments, and very first setup you might want to use or not. In the case of this tutorial video, I'm going to remove some stuff here because we don't want to have that sitting here, and I'll use the comment option here, and we won't need any output for our things, because what we want to achieve is when our light illuminates the surfaces of the objects, we want to create particles. So that's our task. Wherever the light cone is, we want to illuminate, we want to emit particles, and based on the illumination levels. So let me just throw this out as well so that we really start from scratch. So the first thing we have here is our group input, but because we are working with objects and I want to go from the objects and the information we can gather from 3D Studio Max objects, I'm going to have as a first input, and I will use the input description here, we will use objects. I'll just name the port objects, and this port should be of the type objects, obviously. So what that does is it creates an input for our node of the type objects, and this will give us the option to select objects in the scene. So I'm going to create a comment. You should always try to comment as much as you want. But also it's important later on when you want to explore your scripts you wrote, it's always a good idea to have a proper comment there. So input for objects in the scene, for example. So let's just have that as a comment. And the next one is our group, our particle group, where we want to control the particles or where they should be stored. And then probably we want one input to control our, let's say, particle amount or particle count, or however we want to call that. So let's just say Born amount. I just want to control how many particles are born. And this port is probably just an integer number. So we go there and make, sorry, that was a port scalar. And then we are going to make sure that we restrict this input specifically to integer. So I'll go there and choose integer. So what we did here is we created an input with the name born amount of the type scalar, and we make sure it's just integers because we have full amounts of particles. We can't create half particles or a tenth of a particle. So that this is our born amount. So there we go. And the next thing is we are talking about light. So we somehow need to get the light in. So we have to create an input for the light list or list of lights in the scene. And I'm going to name that lights. Who would have thought? And I'm having that here, and our port is obviously for the type lights. So here we go. And again, a little comment. This is our light list. So now we have the first block moving or working. And what I want to do right now is, you don't have to, but I would suggest we do that right now, is press the compile button. And when you take a close look at our node up here, when I press the compile button, it created the inputs. So now I have the inputs for the objects, for the group, born amount, and the lights. So for the group, we already can choose our particle group we want to work with, and that was spray. So right now I set the particle group to spray. So whenever we want to access the group, it will be spray. And for our born amount, let's say we just want to start with 200 particles or points or possible particles in our simulation. So now we have done this, and we can now continue with our actual code to born particles wherever there's illumination in the scene. So the next step is we need to somehow access or get access to our surfaces. We want to get the illumination, for example. Is this face illuminated? And if it's illuminated, what's the brightness or color or whatever? So we need to somehow access this data. And here I want to talk about how do you know which functions are available and how do they work. So what I want to do is I just start with the objects, because this is what we want to access. And now we can see in our autocomplete, it suggests me all the functions that are available with objects. So I can have objects in count, so we can count or get the number of the objects that are picked. And we can also access our objects in parallel. And this is the function I want to use because I want to go over the objects as fast as possible over the surfaces of each single object. So I would choose the objects in parallel as my function I want to call. And now the question is, how do I know that? Well, what does it do? So we have a very powerful help system now. It's an online help system or offline help system, depends how you set up your thinking particles. but you can press the selective help. So whenever your cursor is within a function and you press the S help, it will bring you the text about the objects in parallel. And we can see when I scroll down, we will have it highlighted, and we can see here's objects in parallel. And the objects in parallel has the following parameters. So we have the in object ID. So that means if we have a list of objects, it starts with 0. We can define, okay, I want from the object list, object 1, 2, 3, 4. And if I put -1 there, it means I want to have all objects evaluated. And in this case, I want to have all objects evaluated. So now we can go and have our second parameter we have here, and that's the in parallel type. So the in parallel type has multiple options, so I can just click here and we see in parallel type. So what can we access from the objects in parallel? So very fast and efficient. And I'm choosing, I want to access the surface. So I will use surface as our option. I want to access all surfaces of all objects in parallel. And then I want to define, let me just bring back our help file. Let me just go back with our help file. We have the, excuse me, the options. Let me just go down to our objects in parallel. We have the option of, when we have surface, and this is what we use, we have the option to specify a scalar input index to use as the number of random points on the surfaces. So this is kind of, you need to be careful about or pay close attention to it. Scalar in ID, that means we need to specify now our input where we set the amount of particles or points on the surface. So the burn amount is 1, 2, 3, 4. So that's on the third position. So that means we start with 0 counting, but then we have also the default inputs. So how do we know, how can we supply the index of our input? Because we want the input to fill in the number. So there is one option, born amount in, there's this option born amount in ID, and that's in ID, let me choose that. So that's the important part, the born amount in ID, that is automatically giving us the ID of the input. So we don't have to count or care about when we reorder, because we can now reorder our inputs. So reordering our inputs is a new concept. Usually in TP, you can't reorder your inputs. So if I were to choose the move the port lights, let me say right underneath here, then when I compile, just have a look. Right now lights is on the very last position. Now it's there. So now our born amount is on the last position. So we would have had an issue getting the value from our input here into that. But with born amount in ID, we are automatically getting the ID whatever we resort or reorder the inputs. So that's a very important thing to note and understand. And we also need to, so that our function or node works, we need to add now objects. So I'm going to add an object helper, which is a standard node in 3D Studio Mac in thinkingParticles. So we'll feed in the object. So I'll pick the plane, I'll pick the torus, and I'll pick pick the sphere. So now we get all the objects in. So remember, we are counting from 0, 1, 2. So we have all the objects in now. And the next thing we want to get in as well is our lights. We can have one light or multiple lights. So I'll just connect the lights here. And now we are able to pick our light, and we have all the information we want. All the other information we did with our direct parameter block here, we have automatically created with our inputs, and that is the group and the born amount. So let me just move back. So now what have we done? With this function, we are accessing all the surface or all the faces on the objects, on our objects in the list. So that means all the objects we have picked here, we will access and go through all the surfaces and create this amount of random points on the surface. So the next thing is we would probably need some variables. And variables are defined with the var command, and I'm sure we need to store velocity. So we need a variable to store a velocity value. Then we want, for sure, we want to have the brightness stored somewhere and do some tricks to the brightness or do calculations. And also what's important is we want to store a normal. And these little 3s you see here just indicate that these are vectors. So every one of these variables has actually 3 values, x, y, z, or RGB, or whatever. 3 values. So I think we are good with these variables. And now we want to get some more geometry, topology, relevant information. And for that, I'm accessing the objects again, and I'm choosing the in-geom functionality. And same deal again. How do I know what parameters I need to fill in there? And I'll just go to this, objects in geom, and there we can read all about it, what the function does. It's a very powerful function. It allows you to access face data, vertex data, mapping channels, data, edge data, and a huge amount of data, as you can see here. So, but now, for now, let's concentrate on our main parameters we need to supply. So, oops, it's gone here. So the main data we need to supply is an object ID. So which object do we want to access? And then we need to supply the data we want to retrieve and where to store the data. So let's do that. For the object ID, we have an internal function that will give us automatically the object ID for the object the multi-threading or massive parallel processing is working on. So I don't have to know about that. I just pass in this variable that is my current object that is worked on. And the next information is what do we want to get from this function. And I would say I want to get the face normal. So there we go. I'll tell the function, get me the face normal. And then to get a face normal, I need to supply a face ID. So where does this face ID come from? Same deal. We are going through all the objects, all the faces in parallel. So the code automatically knows, okay, I'm now having face 3622, 3620, blah, blah, blah. And this is stored in an internal variable called FID. So the face ID is there. And then to get the normal, the proper normal of a point on a face is we need to get the barycentric coordinates, and there's also a function for it that gives me the barycentric coordinates and supplies it, and then I want to store this in my variable we just created up here. So we created this vector here, normal, and here I'll get back the face normal into this variable. So we are now having all the surface normals for each individual single surface of our objects. So let's have a little comment here with the surface normal. Okay, so now we have that. The next thing we want to do is work with a normal. So what we want to do is, let me just create and calculate at the same time. You can also do this. We want to know if we hit the back or front of our surface. So I'll have the back front as a variable. And then we can just call our function we have here, where we say lights. So where we get our lights list, and then we want to have the lights in illumination. This is the function we are looking for. That will give us the illumination information we are looking after. So same deal here. We can specify the lights. It's a list, so it counts from 0, 1, 2, 3. So right now I'm totally fine with all lights because we only have one light and I'm lazy to do that. And what I need to supply is a position on the surface, or actually, it's just a position. It could be any position in 3D space where I request my illumination value. So I'll supply WP, that's the world position of our point that is right now evaluated. Keep in mind, this is a multi-threading, fully massive parallel thing that is executed here. So we have this internal variable that gives us the current world position or point in space that is evaluated or worked on. Then I need to give it the variable I want to store the brightness, and I need to supply the normal, which is also a variable we just created. And once more, if you need to know what this function does, just put the caret here and press the S-help button, and you're right there. It tells you what this does, how a call of this function could look like, and what you need to supply to it, and what the return values are. And in this case, if it's below 0 or negative, it's the back side. If it's greater than 0, it hits the front side. So this is how we can say, okay, what's illuminated by a light source. That's what we've done here. And the next thing is, now we want to decide based on what's going on. So we say, based on our back front value, if it's greater than 0, and also we want to make sure if it is above a certain brightness. So I'm using here a mathematical function that's called maximum, and it automatically calculates the maximum of my 3 values. So max gives me the maximum of all 3 values in bright. And keep in mind, bright is a vector, and we fill in the data from our illumination. So we get back the color of the light. And the brightness is just the maximum of all 3. And I say, okay, we need to have some sort of illumination to do something. So we want to hit the front side and have it a certain brightness. Now let me start my if block in here. And the next thing we probably need to do is create a variable for our light position, because we need to do some calculations with the light position. And we need to create an array. And again, we need to be careful. We need to tell the system, hey, I want to do vectors, 3 values, and let's do vectors here. So why do I think I need the position of the light and the array vector? What I want to do is calculate somehow a type of shadow casting. So is there something in between the surface and the light? And that would mean shadow. So what I'm doing now in my next step is I'm getting the light position. So we are getting that with our light in, and then we're going to, lights in, that's our object, lights in, and I want to get from our lights in the position. So I'm calling lights info position. And once more, you can check in the help file what we need to supply and all this stuff. So right now, same deal. Oh, sorry. -1. I want all lights evaluated. And what do I want from the light? I want from this light, I want the lights info position. That is what I want. And sorry, I did a little typo in here. The function is called lights in info. That was my little autocorrect typo here. So I want the light info, and from the light I want the position. And now we need to tell it store the position in this variable, lpos, our light position variable. So now I think we are good, and we have all we need. We store the light position in the light lpos variable. Perfect. And now let's do some calculations. So we want to have our array variable initialized with, let's say, come on, I'm having a hard time typing here and talking into the microphone. It's blocking my view. I'm sorry for that. So we're doing some calculations to get the ray from the light position and the position on the surface. So we subtract the light position minus the position of the surface, and that will give us the ray from the surface towards the light. So now we have, let me just ray to the light. So we have the ray to the light. That's what we need. And now we can go one more. We can say, if we have objects intersecting, so there's an intersect function. If we have objects intersecting, so let's do the objects intersect function, and there we have the same deal. We can say with one object or all objects. So we want all objects. We need to supply a position. So I'll supply the position of the surface. Then we need to shoot a ray. This is what we just calculated from the position from the surface to the light. And then we need to supply the length of the ray, and then we need the object ID. That is, we don't want to hit our own or self intersect, and we need to have a face ID supplied as well. And that's actually all we need to do. And then if this result equals 0, we know we didn't hit anything. So what should we do, or what do we want to do when we did not hit anything? That means we didn't hit anything. So we're going to create our velocity and apply norm multiplied by 10. This is a little trick. So we use the surface normal multiplied by 10 as our velocity. And now I'll create a new particle and give it a particle ID. And sorry, that's our particle group. I'm going to access our particle group now. And I'm using create function. Sorry, here we go. And I'll create a particle. And to create a particle, it's very simple. It needs a position. That's on our surface where we evaluate everything. And I'll supply a velocity. So now I've created a new particle with the velocity we just calculated based on our surface. The next thing I want to do is check out probably if we have a typo or an error. So I don't see any errors. Error is 0. And let's see if that already works. And we can see the light moves. And as the light moves, it creates the particles wherever the illumination is. So how about we increase the amount of particles? Let me just say, okay, let's do 1,000 particles or 1,000 points on the surface. And we can see it's much denser now. And we also see our shadow casting is working pretty nice. So everything that's blocked towards the light will create this shadow-like effect. So from these points, we shoot back a ray to the light position, and we can see the torus is in between, and that means there's a shadow. So that's working beautifully. And as you can see, really, it works in real time inside of 3D Studio Max. And now the great thing is, let me just put that back to 200. The great thing we have right now is we could do more stuff. For example, how about we change the size of the particles? So we could set particle data. One of the most powerful or useful functions is set p data. So set particle data allows us to set for a particle, that's our particle ID. We just created a new particle and we set the particle ID. And let's say we want to set not the age, we want to set the size. And then let's do another little trick. Let's say we want to set the size based on our brightness. And we'll give it a little bit of a shift there and multiply the size by 5 and divide by 0.8, something like that. So what we did here now, excuse me, is we have the we set the particle ID, so that's the particle creator we just created here. We set the size based on the illumination, and then we just multiply it high and restrict it for the brightness values. So that should give us a variation in particle size. And I did miss a bracket in here, and I think here we go. That was my error. No, I mismatched the bracket. I'm still missing a bracket here. So where's my bracket? Oh, sorry. totally mixed that up. We want to have the functions in here, and then we'll have the so here we go. Here we go. Now we have different particle sizes so that we can actually see in the particle size. We would need to apply a particle shape, and then we could see the different particle sizes. And I'm just going to do this in a very simple and easy way. Just go here with spray, and we'll just apply a standard shape. And we'll apply the standard shape, and then we can have cubes or whatever we want to do. And here we go. Here we have our various particle sizes based on the illumination value. And another option to just evaluate and see the size of particles is also we could use our, instead of ticks, the sprite display. And with sprites, we also get instantly feedback of the size of our particles. So that's about it. I hope you enjoyed this video tutorial. I'm going to do some more tutorials about MEL and how we can do amazing things with it. Thank you for watching this video, and hope to see you back again. Thank you.